Now we will talk about the physical layer. Remember that we already talked about different subjects. Typically, we already, for instance, talked about data link layer, network layer, transport layer, and now we will talk about this, that is the lowest layer of the stack, the protocol stack, is the physical layer. Then remember that the physical layer, in fact, is responsible to transmit bit stream over different communication channels in order to exchange bits not only between end system, but between end system and intermediate systems, and between intermediate systems. That is, in fact, is the lowest layer of communication. And in this layer, we need to define typically mechanical and electrical interfaces. That is, plugs, the assignment of each circuit, the physical representation of bits. Typically, we will talk about symbols, the duration of symbols, the baud rate, the relationship between baud rate and bit rate, and that kind of specifications. Remember the transmission media. We already described this during the introduction, but in fact, remember the transmission media are classified between wired and wireless, or guided and unguided medias. Within wired or guided medias, typically there are three types of medias: coaxial cable, twisted pair, and fiber cables. And within the twisted pair cables, we could have unshielded twisted pairs, UTP, shielded twisted pairs, and foiled twisted pairs. And the classification of fiber cables, in the classification of fiber cables, we could have typically two types of fibers, the multi-mode and the single mode fibers. Then, well, only remember the different types of medias. And typically, we start with the first medias that we use to communicate different systems using guided or wired links of communications. In this figure, we could see the typical concept of twisted pair, and in this one, the concept of coaxial cable. And we will talk a little bit more about the twisted pairs. Then twisted pair cables. In fact, twisted pair cabling is a type of wiring in which two conductors of a single circuit are twisted. Two conductors are twisted. This is an invention of Graham Bell. Compared to a single conductor or an untwisted balanced pair, a twisted pair can be used as a balanced line which as part of a balanced circuit can greatly reduce the effect of noise currents electromagnetically induced on the line. Remember, in this case, the concepts behind the Lenz law and the Faraday's law of electromagnetic induction. The twist rate, also called pitch of the twist and usually defined in twists per meter, makes up part of the specification of a given type of cable. For instance, here we are that category 5 twisted pair has in fact a twist rate higher than the category 3 twisted pair cables. This permits to have a better reduction of the effect of noise currents electromagnetically induced on the line, then better capacity or bandwidth of the channel constructed with that kind of cables, of twisted pair cables. When nearby pairs have equal twist rates, the same conductors of the different pairs may repeatedly lie next to each other, partially undoing the benefits of twisting. Remember, in the same cable, there are several twisted pairs, and there is a possible effect of what we know as crosstalk between twisted pairs that are in the same cable. For this reason, it is commonly specified that at least for cables containing small numbers of pairs, the twist rates must differ. A little difference in order to avoid the crosstalk between pairs. Twisted pair cables for additional noise immunity may be shielded. Cable with shielding is known as STP, shielded twisted pair, and without as unshielded twisted pair, UTP. UTP is a primary wire type for telephone usage and is very common for computer networking. Here we are some advantages and disadvantages or benefits and limitations of the twisted pair cables. The advantages or benefits, the twisted pair cables present a better benefit related with the electrical noise going into or coming from the cable because the twisted pair cables could prevent the electrical noise or electromagnetical noise. Crosstalk in the same direction. We could say that crosstalk is minimized because the electrical noise is prevented. Cheapest form of cable available for networking purpose. That is, the twisted pair is cheapest compared, for instance, with coaxial cables and with fiber cables. Easy to handle and install. Very easy to handle. Some disadvantages or limitations. The twisted pair cables are susceptible to electromagnetic interference greatly if they lost the scheme of twisting. That is, twisted pairs susceptibility to electromagnetic interference greatly depends on the pair twisting schemes staying intact during the installation. As a result, twisted pair cables usually have stringent requirements for maximum pulling tension as well as minimum bend radius. This fragility of twisted pair cables makes the installation practices an important part of ensuring the cable's performance. That is, the disadvantage is the possible deformation of the structure of the cable. The delay skew. Due to different twist rates used to minimize crosstalk between the pairs, different pairs within the cable have different lengths and thus different delays. This could be a problem, particularly for some applications like video transmitted across that kind of medias. Imbalance differences between the two wires in a pair can cause coupling between the common mode and the differential mode. But in fact, the advantages and benefits are strong compared with the other medias. The designation according to this standard, the ISO 11801 from the 2002 specify that the cables are identified with that kind of notation. ZZ always stands for TP, for twisted pair. Y stands for the wire screening, that is unshielded or foiled, foil shielded. XX for the overall screening, unshielded, foil shielded, braided umbrella, and braided and foil shade. Remember, braided is a mean of shield cable, like in the case of the coaxial cables. Then here we are, different screens of the twisted pair cables. For instance, this is typically an unshielded twisted pair of unshielded twisted pairs. An unshielded cable of unshielded twisted pairs. Or for instance, this is a shielded cable of foiled twisted pairs. Or this is a foiled cable. Here we are the foil, typically an aluminum foil that shield all the cable, but each pair is unshielded. And this is typically an unshielded cable, but with each pair shielded with foil. And different combinations of screens for twisted pair cables. Depending on then the twister, the twist. Remember this concept. The twister rate makes up part of the specification for a given type of cable. Then each type of cable is identified with a category number from 1 to 8. Then each category has a twist rate and other particular details of construction of the cable. Then category 1 is a very old cable, only used we could use only this cable only for telephony. But typically, the category that we could use nowadays is typically from the category 5 to 8. But we perhaps some installations could have category 3, for instance. For category 3, the twisted pair support bandwidth of 16 megahertz. That is enough to transmit a signal, a digital signal of Ethernet, for instance, 10 megabits per second. Category 4, 20 megabits. It's not very useful. And finally, category 5, that permit to transmit until 100 megahertz, and 100 megahertz permit to transmit digital signal of Ethernet 100 megabit per second. Category 6, for instance, to that kind of twisted pair permit transmit signals of 250 megahertz, and a combination, for instance, with four twisted pairs of category 6 permit the transmission at 1 gigabit per second. And after that, there are other categories of higher rates, for instance, category 7 and category 8 to work at 10 gigabit or 40 gigabit Ethernet. Well, this is typically the connectors, the APAC connector or RG45, and there are typically two specifications, two EIA TIA 568A and 568B with different assignations of the pairs to the pins of the connector. Typically, in a structure cabling installation, we use this standard or the other, not a mix of them. Typically, in order, for instance, to assign the pairs to the different circuits, this is the assignment when we use this connector to connect to the pairs to implement, for instance, a link of 10 megabit with twisted pair, or 100 megabit of 100 base TX, or 100 base T4. The difference is, in this case, we use one pair to transmit and one pair to receive. In this other case, we use the four twisted pairs to transmit and receive. Or, for instance, the assignation of the circuits to the 8 pins of those connectors when we work, for instance, with gigabit Ethernet with twisted pairs. Pay attention that we could transmit at 100 megabits if we use across one pair if we use cables of category 5. If we use cables of category 3, we could transmit at 100 megabits only if we use several twisted pairs to transmit the digital signal.